Today it's Thursday, May the 18th, and here we have an engineering FCOG61 bipolar board with the configuration that we intend to use for connection diagram E2476 for GE China, India, and this has been the latest approved connection diagram, and we want to show when we bring in 480, actually we're bringing in 480, not 415 volts DC. We're going to show what happens, how we control the polarity command, and what happens to the output and how fast you get the maximum output. What we have here, it's a 4 quadrant rectifier. We have 12 SCRs. We have the firing board on top of it, and we're bringing in 480 volts, and the maximum voltage that we're getting is about 610 volts DC. So what we're going to do is we have a switch. Can you show me the polarity switch? Yep. We have a switch that will either bring this P signal that it's normally pulled up down to ground, or we're going to open it to let it go back high. Every time that P is high, the board fires in the positive direction, and when we close that switch, P goes to common, and the bridge now fires in the negative direction. So we have here 475 AC going in. This is the maximum delay angle command. In this particular case, for this board, it will be 0 to 10 volts. In our board, it's 0 to 5. And here we're going to be recording the DC output. So let's go ahead and enable, Tony. So there it is. Right now we have 615 volts DC. Do me a favor, Tony, can you start decreasing sig high, the enable command, from maximum from where you are to 0? So we see that it gets down to 0. Go ahead and transition polarity, and can you go back to 5 volts now on the opposite? Alright, and what we have now, it's 616 volts DC. Now, what we're going to do now is we are going to transition while we are at 16 volts DC. Go ahead, Tony. There you go. Now we are on the negative 615, and this is just by toggling this switch right here. And the last thing that we're going to do is we're going to try we're going to arm it. We are on the negative, so we're going to go positive. Alright, go ahead, Tony. And the approximate time from where we are at full output to the time that we go into full output again this is 10 milliseconds per division, so this is about 10, 20, about 30, 35 milliseconds. Now let's try that again in the opposite direction. And there it is, and again the time it's 10, 20, about 30 milliseconds in this particular case. The last thing that we're going to do is, or what we've also taken here, it's a couple of shots of when things happen, and I will send an email explaining the principle of operation. So this is roughly the end of this video, and what we want to show is the transition time, and hopefully we'll get an approval from GE India that this is going to work just fine for their application.